So today we will complete this topic, polymorphism and abstraction. Let us see what do you mean by abstraction. So when you talk about the abstraction is one of the four fundamental principles of object-oriented programming. It involves simplifying the things. It involves simplifying the complex system by modeling class based on essential properties and behaviors they share, while ignoring or abstracting away the unnecessary details. So goal of the abstraction, here you can say, the goal of the abstraction is to provide a clear and concise representation of real world entities in a program, making the code more manageable and understandable. Making the code more manageable and what? Understandable. Abstraction hiding unwanted details. Hiding what? Unwanted details. So how to do that? Let us see. New folder, day 45, and here I can say ABS, abstraction.js, and into the abstraction what I will do, class shape, class what? Shape. And into this let's add a constructor, and to the constructor we can have color property, and here I can say this dot color is equals to this incoming color, right? And calculate area. See here what is happening. Presently you don't know what shape it is. You getting my point?
Yes.
Presently you don't know what shape it is. Well, I got one very important concept to be covered, so I have forgotten to write it. First let me write it and then we will go ahead. Exception handling. Page. Error handling. Very important thing. Error handling. Okay, we are going to see this. Let's move back. Classes and object-oriented principles, and abstraction. Polymorphism we will see shortly. First let us see abstraction and then polymorphism. Is one of the four fundamental principles of object-oriented programming. It involves simplifying the complex systems by modeling classes based on the essential properties and the behavior they share, while ignoring or abstracting away unnecessary details. While extracting away what? Unnecessary details. Okay. So calculate area. So we have a shape. We have what? Shape. So if I tell you calculate the area of shape, can you calculate that? No, because you don't know what kind of shape it is. Triangle, rectangle, circle, right? So this method is incomplete. This method is not complete. So that's why we are not writing anything into this, because presently we don't know how to calculate the area, right? But the children of these classes, like class, here I can say circle, would be the children of this class. How it will become children? Extends shape. So here is a relationship. Circle is a shape, right? Circle is a shape. That's why circle is extending to the shape. So constructor, here we can say constructor, and we can accept which color of the circle is and what is the radius, and what is the radius. So super, we are passing color to the parent. So whenever you create the object of circle, first invoke the constructor of the parent, that is nothing but this, and then here you can say this dot, sorry, this dot radius is equals to this radius. So when you say this color, automatically this constructor would be getting called and color would be getting assigned. And remember that color is getting inherited from the shape to the circle. Color is getting inherited from shape to the circle. Now let's override the method calculate area. So this method is already there in the parent, but there is no implementation. Why there is no implementation? Because we don't know how to calculate the area of shape. So this can be any shape, but here we exactly know. We what? Exactly know how to calculate the area of circle. So we can say return here math.py. I hope you know area, how to calculate the area, pi r square. This dot radius pi r square into 2 means what? Radius square. Math dot pi r square. So here you can create the object of const circle is equals to new circle. Two parameters need to be passed to the circle. First color red, second radius 2, and then you can call console.log area of circle is circle dot calculate area. So cd dot cd day 45, and here you can say node abs.js. Can you see here? Area of circle is 12,566, something like that, pi r square. So simple thing we have done, we don't know which shape exactly we have over here, but we know circle, how circle, what is a circle, what do you mean by circle? You exactly know, you mathematically define the circle. Yes. Right, and you can calculate the area of circle mathematically, but shape means what exactly? This is something incomplete. So this method is incomplete. This method is what? Incomplete. And this incompleteness in the coding is represented by the abstract class. Now see here, you don't need to worry about how exactly area is calculated. So this, by looking at this thing, calculate area, you cannot say how exactly area is calculated. Unwanted details are hidden, right? Unwanted details are hidden. So you are simply calling circle dot calculate area. So let's write it, abstraction. I hope you got this idea. Yes. Abstraction. So identifying the essential features. So here are the key features or here are the key aspects of the abstraction. Key aspects of the abstraction includes identifying the essential features. Identifying what? Essential features. Creating the abstract classes. Creating what?
Abstract classes.
Creating abstract classes. Hiding implementation details. Hiding implementation details. Promoting the modularity. Promoting modularity. Enhancing the flexibility. So abstraction requires, so here you can say abstraction requires identifying the essential features of an object or a system while omitting the irrelevant details. This involves focusing on the important for current context or problem domain. So unwanted things are removed. Only calculate whatever things are related to the calculate area that are added over here, and people or the callers of this method will not know the internal details, what is happening exactly, right? So abstract classes, here you can say abstract classes are the classes that cannot be instantiated on their own, but they serve as a template to the other classes. So technically here if you see, we have not created object of shape directly because shape is having something incomplete, and because of this incompleteness you cannot create the object of this shape. Hello?
Yes, sir.
Shape is something, what you can say, shape is something incomplete, right? These classes may contain the abstract methods. They may contain the abstract methods, methods without defined implementation that must be implemented by the subclasses. Now see, in the shape there is no implementation to calculate area, empty bracket, start bracket, end bracket, right? So this incomplete method makes this whole class as incomplete. So this incomplete method makes this whole class as incomplete, or in other words, this incomplete method makes whole class as incomplete. In other words, this class would be, what you can say, this class would be abstract class. Abstract class. Abstract classes, few more things about the abstract class. Abstract classes allow for the definition of the common characteristics without specifying every detail. See, we don't know how to calculate area, but we know every shape would be having some area. We don't know how to calculate area of shape. Shape is a very generic term. So at the moment, we don't know anything about the shape. We also don't know how to calculate area for the shape. And that's why we just have written the empty method. There is nothing but this. Abstract classes allow for the definition of the common characteristics without specifying. Abstract classes allow the definition of the common characteristics without specifying every details, right? So abstraction involves, you know, abstraction involves hiding the internal implementation details of a class from the outside world. Abstraction involves hiding the internal implementation details of a class from outside world. Users of a class should interact with well-defined user interface. Presently, we don't have user interface. Users of a class should interact with well-defined interface using methods and properties that represent the essential functionality. Now see here, over here, you need to calculate the area. What you need to calculate? Area. But here you don't know what is happening inside the method. If you, the collar of the calculate area, collar of the calculate area doesn't know what is happening exactly inside the method. How area is getting calculated. These are the bits and pieces of the calculating area. So radius into something is happening like this. But that is hidden over here. You don't need to worry about these things, right? To the caller, the implementation details are not necessary. That's what hiding the implementation details. So abstraction involves hiding internal implementation details of a class from outside world. Outside world means callers, who call the methods, who access the properties. Users of a class should interact through well-defined interface. So if you want to calculate the area, you need to call this method, calculate area. So it should interact through the well-defined interface using the methods. Well-defined interface using methods and the properties that represent the essential functionality without exposing the unnecessary complexity. So here you will not write any code like circle dot radius into. Here you will not do all these things. So these things has to be done internally only. Right? Hello?
Yes.
And that's why you can make a radius private. This dot hash radius. You can make this radius as private. If you remember, we have seen this private variables. Can you see hash balance and this dot hash balance? So hash radius and this dot hash radius. Here also you can see this dot hash radius, correct?
Yes.
Hash makes it private. This is a private, this is a private. So you are not allowed to do anything which is related to the functionality outside the class. That's what the encapsulation is, right? Creating a capsule of the data and its behavior, or creating the capsule of your properties, creating the capsule of state and behavior together, encapsulation. And this is whole and sole concept is a abstraction, class shape, circle extends shape. Here we don't know how to calculate the area. So the circle is a circle is a child of shape class. Circle is a child of shape class. Shape class says that I know every shape will require calculating the area, but right now I don't know. That's why it is an empty method. So here what we have created, a circle extend shape and the calculate area, correct?
Yes.
Circle will calculate area in different way. Rectangle will calculate area in different way. Square will calculate area in different way. Right? But internal details are hidden.
Yes.
Internal details are hidden.
Hidden.
So that's all about
Abstraction.
abstraction. Few more things we need to write. So promoting modularity, here you can say, by abstracting away unnecessary details, code becomes more modular and easy to manage. Abstraction allows for, here you can say, abstraction allows for the creation of self-contained and the reusable components, facilitating a modular and the maintainable code base. Okay. Hello?
Yes.
Just a minute. Yeah. Enhancing the flexibility. When you say flexibility, abstraction enhances the flexibility of a system by allowing changes to be made to the implementation of a class without affecting the code that uses it. Flexibility, which means that if you make change in the calculate area, right, and there is a one more child called as, or let's write it, class rectangle extends shape. What is the area of rectangle? What is the area of rectangle?
L into B.
Correct. L into B. Length into width, right?
Yes. Yes.
So here we can have length into width. Length into width. Now constructor we can have here length, and here we need to have color first. Color for the parent shape. Color is coming from shape, so we need to initialize the color also. Length, width. So here super color, we are initializing the parent, and this dot hash length is equals to length, and this dot hash width is equals to width, right? Now what?
There is equal width.
Equal. Now what? Calculate area. So this method which is coming from the shape class, let's override that method. Calculate area like this. Calculate the area. Return width length into this dot length and this dot width, right?
Yes.
So in
also there is width.
There is width means okay, length into
This dot.
width, right? So here we can create the object of now const rectangle is equals to new rectangle color blue, length 45, width 56, and console.log area of rectangle is
rectangle dot
a rectangle dot calculate area. Now, what is the meaning of this flexibility? That's what we are understanding. Flexibility. What is the meaning of flexibility? Now, when you say flexibility, abstraction enhances the flexibility of a system by allowing changes to be made to the implementation of a class without affecting the code it uses. Okay. Users can interact with the abstracted interface. Users can interact with the abstracted interface, and the internal details can be modified without breaking the external dependencies. Now see, if I make any change in the calculate area of the circle, if I make any change into this method, it will not impact on this method of the rectangle. That's what the flexibility is. Correct? Once again, let me tell you, if I make any update in the calculate area of the circle, if I make any update in the calculate area of the circle, which will not impact on the calculate area. Both are shapes. This is also shape. This is also shape. But if I make any change over here in the calculate area, this will not impact on this calculate area. Why? Because we are providing the abstraction, and here is a parent and child relationship.
yes
Right. Now, this is what you can say the enhancing the flexibility. And let's write live example. Example as below. And write it. Correct? This is what the example for abstraction. Now, what is polymorphism? Next part. I'll write it in a code. So circle shape, rectangle shape. Now I have one more method. I have a function, normal function. I have any function. So this function, any shape area, calculate the any shape area, and I will accept object of shape class. Object of what? Child of shape class. So presently we just have simply called as a variable name shape. We are not using a TypeScript, otherwise we could have defined this as shape. It's the object of this type. Remember that when you create object of circle, you are also creating internally object of what? Shape. When you create object of rectangle, you are also creating object of shape. That's what we have learned into the inheritance. So if you create object of circle or if you create object of rectangle, technically here you are creating two objects, shape and what? Circle. So when you say any shape, I simply call shape dot calculate area. Shape dot calculate area. So here I can pass either circle object or I can pass what? Rectangle object. So here you can check if type of, well, we Just a minute. So here instead of doing type of, there is one more thing. If it is an object, see here you can say shape instance of which class? Shape class. If whatever you have passed, let me complete the code and then explain that. Console.log area is dollar shape dot calculate area. Otherwise, and return it from here. Otherwise, invalid object. Console.log invalid object. So if you see here, any shape area. Now here you are checking if the shape, so whatever you have passed this object shape, so here you will call what? Any shape area, correct? Any shape area. And here either you will pass circle, here you can pass circle, then it should give me automatically, let's comment this out. Now consider that we have developed a system to calculate the shape of any area. Calculate the shape of what? Any area. So I will just create the objects like this and I will simply call any shape area and I will pass object of that particular shape, either circle or rectangle or triangle or whatever, rhombus, whatever. Okay. So here you will check first if it is a shape is an instance of what? Shape. Now remember that this circle is also instance of shape. This rectangle is also instance of what? Shape. Why? Because circle contains the object of shape also. Rectangle contains object of shape also. Why? Because there is a inheritance. Circle is a shape. Rectangle is a shape. So this object, so whenever you look at this is the instance of two classes actually, shape and circle. Getting my point? Technically this is the circle is containing the features from the parent, which is nothing but the shape, and circle is also containing its own features. Circle is containing two types of properties, one which is coming from shape, parent, and circle is also containing its own properties. In the same way, this is the instance of, this guy is an instance of shape and what? Rectangle, which means that rectangle is having both the properties. Rectangle is having properties of shape class as well as the rectangle class, which means that rectangle is a shape of rectangle also. If you pass circle over here, you are passing instance of the circle class, and here you are passing instance of what? Rectangle class. But instance of circle is an instance of shape also. Instance of rectangle is an instance of shape as well. Now let's go here and see. Can you see area is, it has calculated. Now if you pass any some object of string over here, can you see I'm passing string any data, right? Now if you see here, invalid object, because here you are passing which data? String data. So here this will become string, this any data, oh sorry, any data. So this becomes what? String. And string is not instance of shape, right? String is not instance of shape. And that's why it is printing what? Invalid object. So this becomes false and it prints this invalid object. Correct?
Yes.
Now, what has happened over here inside this function? This circle or this shape is acting as circle also. This shape is acting as rectangle also. Means this shape object is having two different forms over here. A form of shape can take a form of circle. Shape can take a form of rectangle.
Rectangle.
So one instance or one object is having multiple forms. That's why it is a polymorphism. Poly means multiple. Morphism means forms. Object is taking multiple forms, and that's why the concept we have implemented over here, this part, is the polymorphism. Shape can take a form of circle. Shape can take a form of rectangle. Right? Shape can take a form of circle and shape can take a form of rectangle. That is nothing but what the polymorphism is. Right? So what is a polymorphism? Polymorphism here is one of the four fundamental principles of the OOPS, and it allows objects of different types to be treated as object of common base type, shape in our case, and different types in our case is nothing but what? Circle and rectangle.
Rectangle.
Polymorphism is one of the four main type. It allows objects of different types. It allows objects of different types to be treated as objects of common base type. Right? This concept enables you, here you can say, this concept enables code to be more flexible and extensible. This concept enables code to be more flexible and extensible, as it follows a single interface to be used for different types of objects. So here shape, this is the shape, this is the shape. Circle is also shape, rectangle is also shape.
Yes.
And both are having this method, calculate area. Right?
Yes.
Now in JavaScript, polymorphism is achieved in JavaScript. Polymorphism is achieved through the dynamic and loosely typed nature of the language. Is achieved through the dynamic and loosely typed nature of the language. There are two main types of the polymorphism in the JavaScript. Compile time polymorphism just a minute. So So in a JavaScript, there are two types of the polymorphism: dynamic and runtime. Sorry, static and runtime. H2, compile time polymorphism. Just a minute. Just a minute. Okay. So here we can say compile time. Compile time polymorphism. Static binding. Runtime polymorphism. Dynamic binding. So JavaScript is a dynamically typed programming language. What do you mean by this? JavaScript is a dynamically typed programming language. JavaScript is a dynamically typed programming language. What do you mean by that? Hello? Variables. One variable can be string at the one line. Same variable can become data on the next line.
Yes.
It can become boolean on the next line. Same variable. That's what the dynamically typed programming language. As a result, compile time polymorphism, where the methods or functions to be called is determined at the compile time is not presently at the JavaScript. JavaScript technically is a dynamically typed programming language, right? So things related to the compilation are not available. So which method to call? So here you are passing circle, here you are passing rectangle. But which method to call? From the circle it should be called, or from the rectangle it should be called. This is totally dependent on this shape variable. But in the programming languages like C++ and Java, this is decided at the time of compilation phase. Which calculate area to be called? Would be from the circle class or it would be from the rectangle class. So calculate area needs to be called from the which class? This is decided at the compile time in C++ and Java similar programming languages. But as the nature of the programming language JS is a dynamically typed, so this feature is not available, right? That's what the compile time binding. JavaScript primarily exhibits the runtime polymorphism, where calls are decided at the runtime. Which method to be called, which calculate area to be called, from the circle one or from the rectangle one, from the circle one or from the rectangle one. This is decided at the runtime. That's why this type of polymorphism is called as runtime polymorphism or dynamic binding, which method to be called is decided at the runtime. Getting my point? This is achieved through the features like method overriding and ability to use the objects between the different types interchangeably. This can happen because of this thing. So in the circle you have overridden the method calculate area. In the rectangle also you have overridden the method calculate area. So calculate area is coming from which class? Shape class. So you need to remember, whenever you talk about the polymorphism, you need to explain what is polymorphism exactly. Shape can have the different forms. This shape can be rectangle, this shape can be circle. It can have a different form. This thing is called as polymorphism. There are two types of polymorphism available in the programming world: compile time and runtime. What is compile time? Calls are decided at the compilation. Which calculate area to be called, from the rectangle one or from the shape one? This is decided at
Static binding.
static binding. And this is a runtime polymorphism, whatever we have seen. This is all about what you can say runtime polymorphism or the polymorphism. Correct? Like this. Well, this is all about what you can say object-oriented principles. We have seen 4 important principles. We have seen encapsulation, inheritance, abstraction, encapsulation, and polymorphism. So please study this carefully. So I will upload the code also. Here we can see JS abstraction, encapsulation, polymorphism. Okay, so I have pushed the code. Documentation is also updated, and tomorrow we will start some utility classes. Okay, tomorrow is off. We'll meet on the Thursday. Wednesday would be off. We'll meet on Thursday morning 10 a.m. Okay? Yeah, thank you.
Sir, in the project,
Mm-hmm.
can I access the analytics?
Just show image, static image. Go to the Google, search pie chart. Go to the Google search bar chart and show 2 images on the analytics page for now. Okay? Yeah. Thank you.